One of the more complicated problems that we have to deal with in equity is when we don't have a constant growth environment. Instead, we may have something where dividends are interrupted or they've been increased because of certain behaviors. Here we've got one of a supernormal growth. Hart Enterprises recently paid a dividend of $1.25, so that would be D sub 0. It expects to have non-constant growth of 20% for 2 years, followed by a constant rate of 5% thereafter. So it has heightened growth for at least the next couple periods. The firm's required return is 10%. Find the value of a share of stock. Well, let's first look at what the dividends would appear to be. The dividend at time 1 was the last dividend multiplied by 1 plus this supernormal growth rate of 20%. So we see it go to $1.50. The dividend at time 2 is nothing more than the 150 of the prior period that's expected times, again, 1 plus this supernormal 20% growth rate. But beyond this point in time, we're going to see things fall into a very particular pattern of just a 5% long-term growth. And I've highlighted that here in gray because we want to be able to look at that really as two different kinds of problems. So let's go ahead and put in what these things represent. So this is, again, the prior period's performance in terms of dividend multiplied by 1 plus what is the long-term constant rate of 5%. Now, since we're going to use this for each subsequent period, I'll go ahead and fix that in there by putting a dollar sign in front of the F6 so that I have an opportunity now to be able to copy this all the way through. Additionally, let me just make this 1 plus the prior period so that I can copy and paste this expression, and we'll carry it out there for a long period of time just to try to give a sense of what this dividend pattern is going to look like in terms of a constant growth model. So we'll paste those in there to be able to look at that. Now, it is a big pattern, and it is problematic to simply have to go through this every time and say, well, how does it look out here at 50 years? How does it look out here at 100 years or 200 years or whatever it might be? We can get a representation of this. Okay, so we've got a $28,000 dividend in 200 years. It's a lot more work than we need to be able to do. And are there shortcuts to be able to get to this? Well, take a look at the information in gray, because this is all highlighting a constant growth model. We've previously seen how to value a constant growth model. It says we don't need all of this information of these periods. All we need is the dividend in the very next period. And we would divide that by the difference between the discount rate R sub S and this constant growth rate. Okay, so standing here at time 2, if we were jumped into the future to time 2 and we looked at our future, all that we would see is a constant growth model. We knew how to value this one period prior at $37.80. Well, what we're going to see here is that if I looked at the cash flows represented by these two items, the dividend happened and the value of the future stream, if I valued this simple cash flow right here using partly the Gordon model, I should get the same thing as if I were to value this entire dividend stream. And this is what we want to try to highlight in here and demonstrate in this case. So let me deal with this full dividend stream first of all and find its value. The way we would value that is we're going to go ahead and use the function NPV. So under financial, we want to go ahead and take a look at our function called net present value. There it is right here. And we're going to try to highlight that. First of all, what is the rate? We want R sub S. And secondly, what are the values that we have? So I'm going to highlight these dividends from time 1 all the way out here, and we'll take it out here for the 255 years that we've illustrated. And when I do that, I find it has a value today at time 0 of $34.09. Now, taking this abbreviated one where we simply said all of this that's in gray is worth at time 2 $37.80. If I was to value just this stream, what I expect to get is exactly the same value. So let me go ahead and now under our most recently used, we'll go with that NPV function again. Use the 10% rate, but now I'm going to value just these cash flows, the $1.50 and the $39.60 that we saw previously, which was the $1.80 that's being paid at time 2, and the value of $37.80 of all future dividends, but valued at time 2. When we come through there, we find that that stream gives us exactly the same value as the big stream right here. That's the case of supernormal growth. Turn it into a constant growth model at some point in time.